Problem 1290. Convert binary number in a linked list to integer. So given head, which is a reference node to a singly linked list, the value of each node in the linked list is either 0 or 1. The linked list holds the binary representation of the number and return the decimal value of the number in the linked list. The most significant bit is at the head of the linked list. What is the most significant bit? It's the largest bit. So this corresponds to 2 to the 2, 2 to the 1, 2 to the 0. The element at the position of the highest value of sorts, that would be the most significant. So 365 in base 10, this is the most significant digit. If it's 1000, then that's the digit. So how do we solve it up? Well, there's two approaches here. One is the traditional math approach. 101 in base 2 is 1 times 2 to the squared plus 0 times 2 to the 1 plus 1 times 2 to the 0. If you do that, that's equal to, if you expand it, that's equal to 5. But what does this require us to know? It requires us to know how long the number is. 2 squared, 2 to the first, 2 to the 0. So is there some way where we can build it from left to right rather than right to left? We're building this right to left here is because we first have 1, right? Then we add 2 to the first times 0. We're going right, right? So that's not the solution here because this requires us to know the length of the number. Hence, we're going to need to do 2 for loops through the linked list. The first one to get the size, and the second one to do the computation. So can we somehow skip the size and get straight to the computation? Well, we can. To illustrate the example, I'm going to use 365 base 10 as an example of how to build a number from left to right. How do we build a number by first putting the 3, then the 6, then the 5, rather than 5, then the 6, then the 3? Well, to get a 3, that's 3. And then 3 times 10 plus 6 gets us 36. And then 36 times 10 plus 5 gets us 365. So how do we get the 3? Well, it's nothing times 10 plus 3, which is 3. So that's basically how we create a number from the ground up, from left to right. And if this were in base 2, we simply just, instead of multiplying by base 10 right here, we just do base 2. So the same logic, 0 times 2 plus, in 101 base 2 right here, time plus 1, right? 1 is this element here, so that's 1. And then 1 times 2 plus, well, the next one is 0. So 0 is going to be equal to 2. And then 2 times 2 plus the last element 1 is going to give us 5. So that's the other way to do it without needing to know the length of the number. So this is what we're going to do, and we're going to program it up in Python. We're going to have an answer called 0, and right, because that's what it begins as from the example we just saw. So while head, that's going to basically say, okay, while there's more nodes within the linked list, and my indentations are off, so int is 0, and while head, we're going to do what? We are going to do the recursion, where the new answer is going to be equal to the current answer times the base, which is always going to be 2, plus the current element at the current linked list node, which is head.val. Afterwards, now that we've considered the value of the current head, we need to consider the next value in this list. So head is equal to head.next. And this is going to finish the loop, right? This is the whole logic we just described on paper. So we return answer when we're all done. So if we run it, it should work, which it does, so let's submit. And there we go, that's the solution.